Hi, I am Dimitris, and in this presentation we'll talk about the unit circle. We'll start with a definition. The unit circle is a circle with a radius of 1 centered at the origin in the Cartesian plane, as shown in the sketch in front of us. Therefore, the length from the center of the circle to any point of the circle will be equal to 1. The circle, as we can see, intersects the x-axis at points A and B with coordinates 1.0 and -1.0 respectively. And finally, the circle intersects the y-axis at points C and D with coordinates 0.1 and -1 respectively. Now, our question is, can we use the unit circle to find the trigonometric ratios of an angle? Indeed, the unit circle can be really helpful in finding the trig ratios of an angle. Let, for example, theta a given angle. We start by drawing this angle inside the unit circle. Remember that a positive angle is drawn in a counterclockwise direction, while a negative angle is drawn in a clockwise direction. Now, if theta is a positive angle, and especially an acute angle, its initial side lies in the positive direction of the x-axis inside the unit circle, and then from that point we go in a counterclockwise direction until we measure out the wanted angle theta. Having drawn the angle theta, we notice that its endpoint, its terminal point, intersects the unit circle at a certain point, let this be point M, with coordinates x point y. Remember that we are trying to find sine theta and cosine theta. Hence, we need angle theta to be part of a right-angled triangle. In order to achieve that, we bring segment MK, which is perpendicular to the x-axis. By doing so, the triangle OMK is a right-angled triangle. And by looking at the coordinates of point M, we get that the length of side MK is equal to y, the length of side OK is equal to x, and the length of the hypotenuse OM is equal to 1, since OM is the radius of the unit circle. Now, if we apply the rules for sine theta and cosine theta, which are that sine theta equals the quotient of the opposite side over the hypotenuse, and the cosine theta equals adjacent side over the hypotenuse, and by substituting, we get that sine theta equals y, while cosine theta equals x. So, the coordinates of endpoint M can be written in the form cosine theta point sine theta. We will now use a new convention. The x-axis will be renamed as cosine axis and the y-axis as sine axis respectively. So finally, we can conclude that the x-coordinate of the terminal point of an angle theta is equal to cosine theta, and the y-coordinate of the terminal point of an angle theta is equal to sine theta. For any questions about this presentation, you can always contact me on the following email. Thank you for your time.